to reiterate the idea of the patterns of I, is that they're a simple pattern that deals with rules of exponents. As you're doing and working with your rules of exponents, remember, anytime you have really x to the third, that just stood for x to the first times x to the first times x to the first, or x squared times x to the first. You can, anytime you have exponent rules, it just means the number of times it's being multiplied together. And you can rewrite it in terms of products, and that's fine. So as we understand where these values and what these values mean, it all goes back to I is the square root of -1. So I to the first power is just I. Okay? Anything to the first power is always itself. When you square something, you're multiplying itself twice. Well, I squared is the same thing as saying the square root of -1 times the square root of -1. Now remember, the square root of junk times the square root of junk is always plain old boring junk. Well, in this case, the junk is -1. Okay. Now you break it into I cubed. Well, that's I squared times I. Well, I squared is -1, and I to the first is just I. So it's -I. And then lastly, to the fourth, you're right. Because I squared is -1. -1 times -1 is always 1. And the cycle repeats itself. So guys, if you remember this, I, -1, -I, 1, I, -1, -I, 1. It just repeats itself over and over and over again. So if I ask you, what is I to the 123rd power? You would do what again? Divide it by 4. Okay. If I take 123 divided by 4, remember, you don't have a calculator. You have to remember how to do shortcut math. Doesn't help you with that. 4 goes into 12 how many times? 3. Is there any left over? No. So then it would be, how many times is, you've got 3/4 left. So that means it's 30, 3/4, or 30.75, if you will. So it's -I. Because what happens here is you get I to the 120th times I to the third. I to the 120th is a multiple of 4, which means it's 1. If you divide it by 4, and then what's the remainder? 1, 2, or 3? And then, so what's I to the third? There's your answer. Yes, ma'am. I to the 123rd power equals -I. That's your answer. That's all it winds up being. All you're doing is figuring out how many times 4 goes into it. What's the remainder? The remainder is either going to be 1, 2, or 3. If there's no remainder, your answer is 1. Do any of those say 0? And that's where it goes from. Remember, divided by 4. What's the remainder? Okay, remember. But wait, there's more you can do with eyes. I know you were just dying to find out. Ooh. What's that? I is the square root of -1. That's what I represents. It's like pi. What does pi represent? Right, 3.14, 159, so on, so on, so on. I is a representation of a value. Pi is a representation of a numerical value. I is a representation of a value that you can't count on in the real world. Imagine. So, like I was saying yesterday, you're going to be, you have what are called complex numbers. And complex numbers are usually written in the form A plus BI.
Is this still 5.4?
Yes, it is. I'm just going to add on the last little bit of 5.4. It's just adding, subtracting, multiplying, dividing. Yes. So we're just going to add to this stuff here today because we got a bunch of review to go over for tomorrow and before we take our quiz on Friday. So when we're dealing with imaginary numbers, technically they're called complex numbers. And complex numbers can be written in the form A plus BI. That's kind of like the proper etiquette of doing it. This value of A is the real number, and that first group is 4. And then the B, and that first one, would be a -1. And then it goes next to the I. So we've been writing our answers like this, like we were doing when we did our homework the other day, or last night we had a couple answers that wound up being imaginary. We would say it's like 4 plus or minus 3i, whatever it could have been. And we knew that's how we wrote it out. The i's were the last value. That, without me telling you that's what the complex form is, that's what it is. Anyway, what can happen here is that we can, what they do is they group complex numbers within parentheses. So when you are adding them, it's quite literally combining terms. What you're doing is you're adding the real numbers and you're adding imaginary numbers. Treat the I value here like you would a variable. So if I'm looking at 4 minus I plus 3 plus 2i, well, what's 4 plus 3? What's -1 plus 2? There's your answer. Okay. When you're adding these things together, guys, if you see a plus sign, it's literally combining terms. The pseudo catch, if you will, is when you're subtracting. When we're subtracting these, notice there's the subtraction symbol preceding parentheses. What do you have to do to the values within the parentheses then? Distribute. You got to distribute the negative. That's kind of the pseudo catch, if you will. Most people will forget to send it to the second term. Time out, what's wrong? About, oh, all right. I thought there was like an actual surprise, like, whee! So, whenever you have subtraction, draw the arrows because it reminds you that you have to distribute the negatives. Okay? So you wind up with 7 minus 5i minus 1, oh, plus 5i. What's your answer? 6. You're treating that imaginary number, even though it's got the imaginary number there. If you start with 5 imaginary numbers, you take away 5 imaginary numbers, don't you have no imaginary numbers? And what's nothing times something? Nothing. Even though you're imagining it, it's still nothing. I should be a philosopher. I would be too. Okay. Which means you can do this. Again, watch your signs, and it's combined like terms. Watch your signs, and you're combining a lot of like terms. One of the things that I would do, I will always remind you guys of, draw the arrows for the distributive property. Because that's one thing that you forget. Draw your arrows for the distributive property. send your negative here, send your negative there, so you know it's 6 plus 2 minus 9i minus 8 plus 4i. Take care of the real numbers first. 8 minus 8. 0. Okay? Negative 9i plus 4i. And there's your answer. Do you have to put a 0 in front of that for a proper complex form? What's that? No, 0 is the absence of value. It's not the absence of absence. I don't know what I'm talking about. Which must mean it's Wednesday. I almost said Tuesday. Wait, you said Tuesday or Wednesday? Okay. Now what do you think you gotta do? Okay. So when you multiply values of I, again, if it's got the I next to it, and you have 5i times a negative 2, multiply the numbers together like you would normally, and if that was an x. That is okay. That's the rule that we're working with here. So if I distribute that 5i to both terms, I get 5i times the negative 2, 5i times I, so I get negative 10i plus 5i squared. What? Is it 1 or 1? Negative 1. Perfect. So this is, and what happens here, guys, I squared is always negative 1. So what's 5 times negative 1? Negative 5. So that means my answer then would be written as negative 5 minus 10i. Okay? Put my real numbers first before I put the imaginary stuff together. Yes, ma'am? You should. Okay? We're not going to be dealing with things that like third degree. So anything squared, we know that I squared is always going to be rewritten as negative. Yeah, guys. Kind of, until you get the I squared and then it's negative 1. Standard, same thing? Or what do you have? Okay. Now, watch what happens here. Oops, lost it. Ladies and gentlemen, there's a lot to get through here today, and I'm already behind. Aren't those two binomials? Which means what do you have to do when you have to multiply binomials? FOIL. So you have to FOIL and then combine like terms. Which means, should you have an I squared when you're done? Should you have it though? No, because what's I squared? 1. Okay. Are you like this all the time? I'd say lately you haven't been like this, so it's kind of weird. Rough life. You know, I'm going to take some time off in the middle of the day, ladies and gentlemen. I'm going to go sleep in my truck for a while, go get a coffee, and I'm going to come back, and then maybe I'll teach a class. You know, I'll see how it works. But maybe I won't. I don't know. First, negative 7. Outside, 14i. Inside, negative 4 times negative 1. And then a minus 8i squared. Now, What's negative 8 times I squared? 8. Because it's negative 8 times negative 1. So this is plus 8. This is an 18. And this is still a negative 7, which gives me?
Can we put the 18
It should be written like that. Are you technically wrong? Bless you. You're wrong-ish. But if you wrote it like that, I know you knew how to math, you just forgot etiquette. I mean, it's like you had your feet up at the table, or you were chewing with your mouth. Yeah, elbows on the table. You were chewing with your mouth open. You were using the wrong fork. You know, you were using you used the tablecloth as a napkin instead of the napkin. Etiquette. All right, let's try something different. So let's see. We have 6 plus 3i, 6 minus 3i. It is a special case. Now, if you recall, what would have happened if it was x plus 5, x minus 5? What's that? There'd be no middle term. You want to be in the difference of squares, right? If you FOIL it out, you have x squared plus 5x minus 5x minus 25. Middle terms go out, and you want to just x squared minus 25. Okay? That's still called a difference of squares, but watch what happens when you have the I values. If you FOIL it out, you get 36 minus the 18i plus the 18i minus 9i squared. What happens to the 18i's? Cancel out. Okay. What's negative 9 times I squared? 9. What's 36 plus 9? Okay. You can still get a difference of squares with imaginary numbers because sometimes you need to use difference of squares. Okay. For example, when you have to divide. Oh. When you have to divide imaginary numbers, even though you can talk about them, they don't belong in the denominator. Kind of like radicals. We don't leave radicals in the denominator. We rationalize. Well, we kind of do the same thing with imaginary numbers. But in order for us to rationalize this imaginary, what we do is we multiply by what's called its conjugate. What that means is you're multiplying by what makes it a perfect square. Okay, so you think about difference of squares. If it's 1 minus 2i, it would be 1 plus 2i. Because if I FOIL that out, what happens to the i's? They go away. You multiply by their conjugate. You did this last year when you had, or maybe the year before, if you had 2 over 1 plus the square root of 3, in order to simplify that out, you have to multiply by its conjugate. 1 minus the square root of 3. So if you did that, you'd multiply the top and bottom by 1 minus root 3, and then you would FOIL all that through. Because what is 1 minus root 3 divided by 1 minus root 3? It's 1. Okay? It's just a funky form of 1. All right? Yes, sir? Because if I did 1 plus root 3, I would have a middle term with the roots. I need to create a difference of squares to eliminate the middle term. If I did this and I FOILed this out, you'd get 1 minus root 3 plus root 3. And what's root 3 times root 3? Root 9, which is 3. And that's how you were able to get rid of the radicals. You're doing basically the exact same thing with imaginaries, but you have an I value, not a root. You're going to do a lot of foiling and combining like terms. Yes, sir. Yes, sir. Because you're creating the difference of squares. By creating the difference of squares, you no longer have that middle term. When I had x plus 3, x minus 3, when I multiplied that out, I had x squared and then minus 9. I created the difference of squares. Now, when you're working with these with the imaginary, I would suggest that you take care of your denominator first. Foil it out. You got 1 minus 2i plus 2i minus 4i squared. The 2i and the negative 2i drop out, and you wind up with negative 4 times I squared, which is it 4 or negative 4? It's 4. So your denominator becomes 1 plus 4, otherwise known as 5. Take care of the denominator first, because if you do it correctly, it should just give you a number. Okay. Foil out the numerator like we did earlier. We get 5 plus 10i, 3i plus 3i, and then it's plus 6i squared. Well, that means I get 5 plus 13i, and what's 6 times I squared? Negative 6, good. So my final answer is negative 1 plus 13i all over 5. Anytime you have I squared, you rewrite it as negative 1 and multiply them together. There's no longer an I value in the denominator. We change the format of it by multiplying by its conjugate. Okay. Kind of gross. Yeah, it just say simplify. Yep. Just says simplify. Okay, let's try another one. Can you have it with radicals too? Sure. What's that? Nope. You kill a puppy. You cannot simplify over addition. It's bad. No, it's just bad. Think of something evil and bad. Killing puppies is bad. That's a figure of speech. Yes, it is. Yes, ma'am. I'm sorry, what? What do you mean? Yep. Yep. So, what's the conjugate you got to multiply by? No, all you have to do is just 10, root 10 plus I. Oh, I thought you said negative 10. I'm sorry, I didn't hear you. I swear I thought you said negative 10. So when we're multiplying top and bottom here, it's just root 10 plus I. Okay? What's the square root of 10 times the square root of 10? 10. The middle terms drop out. By multiplying by the conjugate, you're doing a difference of squares. Your middle term won't be there. So I can write minus 10i plus minus root 10i plus root 10i, just know that they're going to cancel out, or I can say, well, I know they're going to cancel out. And I wind up now with minus I squared. What's minus I squared equal to? 1. 1. And then I distribute the numerator. Again, what was the square root of 10 times the square root of 10? 10. my final answer would be 10 plus I root 10. Now, imaginary number goes in front of the radical. Whole numbers go in front of the imaginary. That way it doesn't look like the imaginary is underneath the square root. That would just be awful. In the numerator, I distributed the square root of 10 times the square root of 10 plus I. That's right in that second. What? Sometimes I just. So you have 3 minus 2i divided by 4 plus 3i. Now, what's your conjugate? Okay, good. So your conjugate is 4 minus 3i. So you multiply top and bottom. Again, take care of the numerator, or sorry, take care of the denominator first. It's usually a little bit easier. If you do this correctly, by writing out, if you write the conjugate correctly, the middle terms drop. So you don't have to worry about the, plus 12i minus 12i. You don't have to do that. But you get 4 times 4, which is 3i times negative 3i, negative 9i squared, which is 9. And then you set the FOIL out the numerator. FOILing out the numerator, we get, what's that, 12 minus an 9i minus an 8i, and then it's plus 6i squared. Since it's a plus 6i squared, I can say that is now negative 6. Good. So what's 12 minus 6? 6. So I get 6, negative 9 minus 8, all over 25. Okay. Have you figured out the pattern yet? What is that? What's the pattern for your denominator? It's a number. Okay, how do you get that number every time? So when you multiply by the first one by the first one, what do you call that? Squared. What's 4 squared? What's 3 squared? What's 16 plus 9? What's the square root of 10 squared? What's 1 squared? What's 10 plus 1? What's 1 squared? What's 2 squared? What's 1 plus 4? Doesn't help you until you figure out how to do the numerator. This is still simplifying. Yesterday, you were solving the equations, you had to work your way backwards to it. Like I was saying yesterday, working your way backwards how to solve for x is something you didn't do correct. You just had to add an extra step. Yes, ma'am? What? You ask the questions, you always have your phone.
Well, I'm reading a text message
Yeah. Hey, hold on a second. Let me answer this text message for somebody else. If that happens in college, you can say, "Get the hell out of my room. I don't care what you're doing." The teachers won't care. Well, you should have been on your phone. It will always be positive because when you have a difference of squares, you're creating that first term minus the second term squared. But then when you square an I squared, it becomes minus something times a negative 1. So it'll always be a positive value. Yeah. Because when you go through all of it, this becomes 1 minus the 4i squared. But what's I squared? So it's 1 minus 4 times the negative 1, which is 1 plus 4. That's where the pattern of the negative 1 equaling I squared comes into play.
But what if you're adding them?
What do you mean?
Oh, yeah, never mind.
Because you won't get,
You're right.
in your denominator, you won't get that. In your numerator, you do. Yeah. Yeah. Numerator, you won't have to do it. Denominator will. Okay, so what I did was I took a bunch of problems off some older worksheets and stuff, and I just kind of pieced them together so that we've got problems of simplifying, solving equations, factoring, graphing, labeling, all that kind of fun stuff. And I'll show you which ones I'm talking about that I want you to at least get through today. Oh, that's 6. I can count. SMRT. So, So on one of the sides it says solve the equation, then there's the numbers 1 through 6 on the very top. That's the side I'm talking about right now. Right? Then in the middle of that, there's a bunch of solve the equations. To the right of that, there's some solve the equations, some fraction stuff thrown in the corners there. Now, at the very bottom, it says perform the given operation of the complex number. That's just what we did. I'd like you to get those, at least those 9 at the very bottom done for tomorrow. That way you can go make sure we did adding, subtracting, multiplying, dividing fine. And then I would start working my way up. Solving equations. Some might be imaginary, some might not be. All through under here. And then tomorrow I've got some stuff to talk about. How do we go back into the idea of graphing, labeling where our axis of symmetry is, how do you find your vertex, directions, max mins, all that kind of fun stuff. That's all what we'll look at. Tomorrow I've got more problems of those, as well as factoring. So I would do, it's just before, it's basically I'm saying start here, work your way up. I wouldn't say that you have, there's a lot there. I would at least get those bottom ones done and then practice a couple of the other ones because they're what you did like what you worked on yesterday. So if you did fine yesterday, you should be okay. I would just pick a couple of ones that have the fractions just in case you forgot how to work with those. Okay, and then we'll go through a bunch of them tomorrow and then continue ourselves through. Yes, Andrew, what's up? What's that? Yeah, sure. We'll talk more about that stuff tomorrow. Here, take a sheet and take a look at the steps. Yeah, tomorrow we'll go through again and talk about how you, all the 3 different ways of graphing, standard, vertex, intersect, how each of those pieces are interrelated, how everything works themselves through. If you go back through your notes, you'll see that we talked a bunch about them for a few days last week, as well as the factory.